Unfortunately, in New Zealand, I'd say he's the guy
And they call it a mine.
known as $100 note guy. Lair, is he on the New Zealand? He is from New Zealand originally. Oh my god, is he on the $100 note? Eltrazi, thank you so much for giving Opinion at a gift sub. I really appreciate it. Thank you. Welcome in, Opinion. Jesus, no one here is allowed to come in here without a gift sub beside their name. Me, and me. That's one way of looking at it, Oz. Something in the Way by Nirvana. Oh, Kiwi! That's a great emote, Wombat. They have some of his science stuff on there, but I don't think people pay attention or see it often. Oh my god, I want to see it now. I'm looking this up. What did you call it? A $100 New Zealand note. Is it dollars you use in New Zealand? Dollar New Zealand note. Oh my god! Okay, let me show it to you. Let me go here. Monopoly money. Where is it? Gaming? No, research papers is the overlay I want to use. There we go. New Zealand 100 note. I don't see any other science stuff on it. There's a graph. Oh, is that the decay? I can't see properly. Can I click into this? Hopefully it doesn't send me into a weird place. That might be the decay of atoms, but I can't see what's on the axis. Lord Rutherford of Nelson! Oh my goodness, it actually is him. That's mad. One day Tofu will be on the $100 note. We're part of Europe, so it's I'd have to conquer all of Europe, not just like I'd have to conquer all of EU to get my space on the €100 note. You are part of Europe now, yes. Yeah, but like it's okay to conquer, you know, the hearts of the Irish and get my name on my face on the Irish coin, but I have to do it for all of Europe. You know, that's a feat, you know, to be the best of the best there. No tofu on the UK monies. Hi, Spooky. You're young, there's time. Oh, that's really, really cool. Thank you for that little fact. I really appreciate that. That was really cool. So yeah, Rutherford was born in New Zealand originally. His full name, listen to this. This is his full name. First Baron Rutherford of Nelson. There we go. He is kind of dubbed as the father of nuclear physics, though there's a lot of people who are titled father of the nuclear physics, so there is kind of like debate. But I do think he does need to be given a lot of credit. The amount of stuff he did was really, really incredible. That's way too short to be an actual Nobel title. Ah, yes, nuclear daddies. Don't we know them well? Don't we know them well? Some important stuff that he did become after, obviously he won the Nobel Prize, all that good stuff, blah, 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 that's boring stuff. He became director of the Cavendish Laboratory at the University of Cambridge. I don't know if you guys know Cavendish Laboratory, loads of cool stuff in there. Under his leadership, by the way, he didn't stop there. So he did all of his gold foil experiments, which is incredible. But do you know who under his research group was? James Chadwick. What did James Chadwick discover in 1932? You guys remember? Really important discovery of the with the atom. The demon. Oh, stop, Bog. Don't mention the demon. He discovered the neutron. Exactly, the neutron. The neutron was discovered in 1932. Absolutely amazing work as well. Because I'm not trying to say that scientists had it easy discovering the electron and the proton, but it was a little bit easier to detect something that had charge. The neutron was hard. Like, that stuff is hard to detect, and you had to really think about it. I actually don't understand the experiment properly. Oh, I feel like I remember the experiment on how to discover never mind. My bro found the new James Chadwick, but it was under Rutherford's leadership in Cavendish Laboratory. I'm just reading here. His death, 1937. He was actually buried near two very infamous people. Number 1, Charles Darwin. Number 2, Isaac Newton. He's buried in Westminster Abbey. How did he discover? It was, if I'm not mistaken, it was the oil drop experiment. We can do a whole session on that. So he was born in New Zealand. He moved to Scotland. We know that. I'm referencing a few sites. One of them being Wikipedia, and the reason why I'm referencing Wikipedia is because for some reason the articles aren't talking about the alpha detection. Like, it's really hard to find a good article or a good book that is referencing his work before the gold foil. Like, everything is flooded with the gold foil. Yes, but we use it interchangeably with famous. It's the same thing as factoid. Factoid has changed now, so I'm still standing on that ledge. Kind of similar fission. I think I still actually subscribe to Wiki. I still give them $2 a month, I think. I used to, anyway. As good a hill to die on as any. Okay, so here's the interesting stuff. Scientific career. Okay, this is a very interesting. I'm keeping an eye on the Wikipedia article about this. Just so to explain, I'm using the Wikipedia as a guide because I know a lot of this backstory already, but I just need to know what to say. But I'm just reading the article, and it says, when Rutherford began his studies at Cambridge, he was among the first aliens in Cambridge. And what they mean is those without a Cambridge degree who were allowed to do research. The coolest thing about Rutherford, though, is his supervisor. The one who he was working under. So, before the Rutherford model of the atom, chat, do you know what was the model of the atom before Rutherford? You're not fooling anybody, he's from outer space. What is that cat emote with alien? Glorp. Bohr's, no, Bohr's is way after. Thomson's model, excellent. What do you guys remember? Einstein's jam donut model. Jimmy, I know you're joking. But it's actually very, very close. The plum pudding model. Wait, it is the plum pudding model, or am I making that up? Someone said that I'm wrong. I don't think I'm wrong though, am I? It is, okay. It's okay to be wrong, but I was like, oh Jesus, I got my history all wrong. Yes, so J.J. Thomson is the dude who had the model of the plum pudding model. And so the plum pudding model, I suppose we'll just talk about it really quickly here. The model that existed, but I don't like plum pudding. Yeah, what the flux is plum pudding? Chat, what is plum pudding? Have you ever had it before? I've never had plum pudding. We need a current jam system. Hi, Horseman. Hi, Metal Rain. So, a plum pudding model that existed. So, sorry, if I'm cutting out, let me know. I'm going to put up the mic up here so I'm not cut out as much. Just bear in mind, I might not be perfect about this. I haven't studied this in years. This is just from memory. I know I have like a few articles in the background, but they're all about, what's his face? Rutherford. So I'm just adding context as I'm going along. So the plum pudding model by J.J. Thomson was the idea that you have like a mold, what's the word? A dumpling, kind of like of clay. And what you have in there is embedded protons and embedded electrons. So you have stuff in there that's positively charged. And you also had embedded and stuffed in negatively charged particles. If anyone wants to correct me, please do. That's what I'm describing from memory. Oh, it's like Christmas pudding, is it, Hacks? Take care of yourself, Alex. Thanks so much for stopping by. I always figured plum pudding was British food. I think it is British. Can any British confirm or deny? Well, actually, Hacks is from Scotland, right? Is it very similar? I would call it chocolate chip. Yes, can confirm. Excellent. Okay, we can confirm. No clue. So yeah, so that's what a plum pudding model looks like. The idea behind it is that it's like mold, and not molds as like a molded clay shape of a cake, and in it you squish in positive protons and negative electrons. Okay, it's a very old school. Our puddings are very, very thin. Oh, are your puddings kind of like runny mousse? I don't know if that's the right way of saying it, but are American puddings like runny mousse? Like runny chocolate mousse. So what is cake made of? We're looking very philosophical. More like goop. Oh, not runny. Okay. Okay. Maybe I'm getting it wrong. Okay, so just to kind of get back on track. So that is what the there we go. So he was working under J.J. Thomson at the time, and that was his model. Okay, that's not relevant. I don't need it myself. So Rutherford worked on a few things. He was working on electromagnetism for a little while, but then he went on to work on radioactivity. Specifically, what he was actually working on initially was X-rays on gases, which led to the discovery of the electron, the first results presented by Thomson. So part of that group, what's really, really cool and impressive was that he was part of the group that did discover the electron. Really, really cool. Vix, I really don't know what to say. The overall advice is always to work hard, study, all the good stuff. Unless you have a very, very specific question, I don't know what other kind of advice I can give you. To you individually, everyone is unique in what they find in terms of studying and enjoying in physics. So I'm not sure what you're looking here from me. Custard is a better comparison, maybe. Oh, I used to like custard when I was younger. No, I didn't. It was condensed milk. If the protons and electrons were embedded in something, what was this something made of? I guess that's what they were trying to discover. They could have thought that it was some sort of ether. Well, not ether. Some sort of force, maybe. I'm not sure. Yeah, maybe they didn't know. That was the whole point. They were only discovering the atom at the time, and they didn't know. This was still at the time of a lot of controversy, by the way, about the atom. It wasn't accepted across the board by all physicists. And just to remind you a little bit about this and why it's so important and why there was such a phase shift in physics in this time. around the early 1900s, just the turn of the century, there was a shift. Like, the idea of the atom was only existent amongst young physicists and scientists. Maybe not necessarily young by age, but young by mind, in the sense that they were always actively looking for new things, always actively pushing grounds. But the problem was that in royal societies and in all places of power, the people who were in controlling positions in physics and science were old school physicists. A little bit of gatekeepers, exactly. And so we know so many stories about this. We know so many people had ideas and concepts of the atoms who were pushing forward. And if you had a concept or an idea of the atom, it wasn't so much hated if you were studying purely the atom, but you were very scrutinized and hated if you were assuming the atom existed while doing additional physics, i.e. someone like Ludwig Boltzmann. He was studying entropy and described the equation of the second law, entropy, assuming the existence of atoms. And he was absolutely shunned by his peers, which, again, it's not because of them he did commit suicide in the end, but it was a huge driving force at the time. He was going through waves of depression at the time. What about the atom and Eve? Hi, Bunny Hero, welcome in. So there had to be a huge change in physicists in the early 1900s with people like Einstein, Boltzmann, all those people. And there was actually another interesting change. And I'm so sorry I'm going on side rants, but if it's okay to talk about it. There was another huge change. And what I find so freaking fascinating about this is that Einstein in the turn of the century was considered the new scientist, right? The new leading science in general relativity and all his ideas about the atom as well. He worked so much around this field, photoelectric effect, all that good stuff. And then something like almost 30 years later, he was considered old school. Himself and Schrödinger were basically pushing back against Bohr, Heisenberg, Pauli, all of those other scientists, if maybe the names are clicking in your head, were pushing back against their work because it was too, crudely put, new school. And as you guys know, the infamous photo and the Solvay conference photo, this infamous photo, there is so much drama. This is... Oh, there's so much drama. So where do we see? We see this is Einstein and this is Schrödinger here. Where's Bohr? So there's Heisenberg. Is that Bohr? I think that might be Bohr. Oh, there's de Broglie. There's de Broglie, the guy who I kept mispronouncing the name. Oh, sorry. You guys don't see. You guys don't see. My bad. Oh, a Twitch photo. Hi, Nerdwino. Welcome in. We call him De Bro now. We do. How are you keeping? I saw your video about the moon landings. The three moon landers, I guess. De Broglie hype. So, here's Einstein. Here's Schrödinger. That's Curie. Madame Skłodowska-Curie, which we'll talk about next week on Sunday. There'll be a whole video about her. That is, if I'm not mistaken... Wait, no, that's Pauli. I'm pretty sure that's Pauli. That's De Bro. That's Pauli. It looks like him. Which one is Heisenberg? I need their names. Here we go. Oh no, that is Pauli and that is Heisenberg. Oh, Bohr is right in front of him. Oh, okay, I wasn't looking in the right row. Sorry. So this is Pauli, this is Heisenberg, and this is Bohr right there. We're uncertain which one is Heisenberg. Didn't they exclude Pauli? Oh, okay, fair enough. Those are good memes. Yeah. Valid. Just before I say who that is, I just want to confirm that, yes, that is Planck. There's Planck beside Madame Curie. Not Heisenberg, Heisenberg. Ay, ay, ay. Okay. Yes, we have a lot of quantum jokes coming in here, Gifty. Perfect time coming in. Anyways, the joke behind this photo. Let's have the names here. Oh my god, absolutely amazing people. I can talk about this photo all day. But just a quick thing about this photo. Number one. So in front of you have oh, that isn't Schrodinger. Einstein, where's Schrodinger? Oh, there he is. So you have Einstein and Schrodinger here in the center. Oh, this is so sassy. Okay, look at this. So you have Schrodinger here, Einstein. There's a few people who have like broed up with Einstein and Schrodinger, specifically behind Schrodinger. Schrodinger's wave equation was the thing at the time. They were arguing for a long time. And then Heisenberg and Bohr, right there. These two were basic, and Pauli was a student as well at the time. He was still young, but they presented at this work their understanding of the atom at the time, and they had a lot of pushback a few years before that, but they did. I can't remember top of my head exactly what they proposed, what equations they were doing, but they showed what their equations at the time. And what was really important at this conference, at this Solvay conference, was that this was where they accepted Heisenberg's and Bohr's idea of the model atoms, the model of the atom at the time. If you look closely, you can see Pauli being a shady little sassy bunzo or a bambino, and you can see that he's staring smugly over at Schrodinger as this photo is being taken. Just some backstory and stuff. I got a lot of this story from Jim Al-Khalili, again, a science communicator that I can't express enough. He goes into depth about the history of these kind of things. Really, really good. I expected Planck to be much shorter. Yeah, you would. Don't want to talk about Lorentz transformations. There's Dirac, who came up with, which equation did he do? Oh, what was Dirac's equation? Was his antimatter? I think he was the antimatter guy. He was trying to put two things together. Was it like the behavior of electrons but in multiples? And then when he did it, he accidentally discovered, or mathematically it was shown, that matter all had antimatter, which was quite spicy at the time. That was controversial. So much drama in the science community. Yeah. Are any of these people not well known? I don't know who Herzen is. Verschaffelt, I don't know who that is. Don't remember Knudsen. French pronunciation, De Broglie. I'm sorry. I made 4 videos pronouncing him De Broglie, and then we realized it's De Broglie or something of that. So we call him De Bro now. He's De Bro. I don't know why, but he is now, and I'm so sorry. That's actually a great question. To comprehend, how do you pronounce Debbie? This guy. Debai? Debbie? Because in quantum and in statistical physics, I don't cover his name too often. So I'll cover his temperature. And predicted, yes, thank you for confirming. Boom. Hi, old man fellas, welcome in. Herzen was a Belgian chemist. Okay. I don't know of any of his equations or his name. Usually I would know these names if there was an equation or a constant. In which oh, is Debbie not French? Is this guy not French? I thought he was. Whoops. I assumed Debbie was French. Picard is best known from being Jean-Luc's great... Yeah, they do say that, supposedly. I did an episode about that. So yeah, Picard was a physicist, chemist, explorer. He did some experiments in balloons. He went up in balloons to study cosmic stuff and tested some stuff for Einstein as well. He did a lot of work. It's such a burn not knowing anyone's equation in this picture. I'm sorry. Oh, he was Dutch American. Oh my goodness. I thought he was I thought he was French. Whoops. Dib-I. How you pronounce it. Dubai. Sounds like Dubai. Yeah, Wiki suggests... Okay. I've always pronounced it as Debbie. It's because of the mustache. Fair enough, fair enough. Yeah, I'm trying to... I think those are the only guys I don't know. Yeah, the rest I know. So I don't know Verschaffelt. Herzen. And I don't know if I know Knudsen. I'm not sure if I know who Knudsen is. I think I do. To be fair, I did think Debbie was French before I even saw a photo of him. It was back when I was studying quantum. Wiki suggests that both the broccoli pronunciations are okay. No, look, I'm happy to have a laugh. Anyways, why did I show you this photo? Oh, I wanted to show you the sass between Pauli and Schrodinger. It was a big thing at the time. Oh, yes, I remember now my sidetrack. I was talking about old school and new school physics, and there was a battle. The whole story, or the whole like irony about it, is that right at the turn of the 19th century or 20th century, Einstein was considered new school, right? And he was pushing away all those scientists who were old school. And yet at this conference, he was the boulder to pass, because this conference was on over a weekend or like several days. And so when Bohr and Heisenberg and Pauli were presenting any of the work, they would, you know, what's the word? They would call him and, or ask him loads of questions, and they'd have to think about the answers, and they come back. And every day Einstein would ask questions, and every day Heisenberg would come back with answers, until the point basically Heisenberg was defeated. Not Heisenberg, Einstein was defeated. He couldn't come up with another question that wasn't answered via their theories, and so they had to forfeit. Not forfeit, but accept their ideas. Is string theory new school now? I've no idea. I really don't know, Baltarazi, what the story is with string theory. I know that there's loads of backlash and there's loads of stories about it now. Supposedly that there's too many string theorists or something like that. I really am out of the loop. This is clearly completely out of my realm. I am not a theoretical physicist. The idea of today's talk was to be an applied physicist or talk a bit like an applied physicist. We were going to talk about Rutherford specifically because I do admire him as an applied physicist. He really is incredible. And he was actually, what's the word? Not condemned. Oh yeah, he did have a big battle with Bohr. It was Bohr versus, well, it wasn't Bohr versus Rutherford, but Bohr and Rutherford were like two polar opposites, where Bohr was so theoretical. It was the pure essence of theoretical physics at the time, while Rutherford was the pure essence of an applied experimental physicist, and the way their brains worked was amazing. Hi, Cake, by the way. Big battle with Bohr. Big Bohr battle. Exactly. I don't think they had much battle with each other. Can't remember. I don't know if there's much lore about the battle. But mostly that they were developing the theories of the atom, but two very, very distinct different ways. Rutherford was very experimental in his ways, while Bohr was very theoretical in his ways, mathematical. It seems they're featuring you in other fields. Yes, Captain Sunbeam. Tomorrow, after my stream, I'm going to be on Science's stream, and I'm going to be talking about me in physics. So I'm going to draw and prepare stuff on the whiteboard. Is this 19? No, way before. This is 1900s, even before 1900s. Something like 87, 97 or so. No, let me double check. Sorry, which part of the question are you asking? We've talked about a lot. I apologize. So all of his discovery, his work is really early 1900s. Combat hole. And the Savoy, or Solvay, sorry, I'm not sure how to pronounce it, Solvay conference was in 1927. Always love to walk past and think about the maze. Oh, I think I want to go there, Nardino. Just go for that. Would be a bit awkward in the 40s. Half of them in the Manhattan Project and the other half work for... Yeah. It was basically one or the other. You were either in the Manhattan Project or you were working with the Nazis at the time. I think Heisenberg was with Germany at the time. Cool, I'll try and check it out, Gifty. I'm doing my best to catch up on books. I'm also not enough time. You think but aren't certain? Okay, let's stop with the quantum jokes now. The quantum jokes aren't going to stop. Okay, so where was I? Okay, so Rutherford worked with Thomson at the time of the discovery of the electron, so he's part of the group. I don't know how part he was. I know he was in Cavendish laboratories at the time. I'm not sure how involved he was, but he was part of it anyways. So Rutherford did start working on radioactivity at this time, and this was when Henri Becquerel was working on uranium, and he came up with the conclusion or discovery of two different types of radiation or radioactivity, which was alpha and beta. He coined the terms, especially that's probably the coolest part, that he coined alpha ray and beta ray. I'm in 2 months. Oh, cool. Thank you, Captain Sunbeam. It's really, really cool what science is doing. Okay, so here we go. So for a long time, he worked with Thomson in Cavendish Laboratory, but then he got promoted, or he needed to pursue physics and science on his own, and he needed to be independent. And so he traveled to Canada. Maybe there's a better website to describe where he was in Canada. I don't know what university he was in. The article doesn't say. I don't know what university he was in. Oh, I found it. McGill University in Montreal, Canada. There we go. Montreal. Hi, Kung Pa. Welcome in. And here he worked on detecting what this weird particle coming from thorium was. So they knew it was a noble gas. How did they know it was a noble gas? Does anyone know? So they didn't know what element it was or what it was at the time, but they knew it was a noble gas. My music stopped. Why do I have so many Wikipedia pages open? I have Debbie and Solvay and a bunny photo. Okay, well, the bunny photos. It wasn't shoveling shit. It spoke in a really posh way. No reaction with any. I think that's the part, Azir. I'm not sure. I'm not actually asking a question. I'm not asking you as in like I know the answer and I'm testing you. I genuinely don't know. I assume it just didn't react to things, and that's what they knew. Why they knew it was helium. But small thing. It wasn't a helium atom, it was an alpha particle that was emitted. And alpha particles are positively charged, and they would in fact react with things. So I don't know. I don't know how he knew it was helium. I need to look into that. Someone said, we want to see the bunny. And I don't know how to describe to you, but I'm a sucker, so I'm going to show my bunny again. Bunny that I'm adopting next week. Or this weekend. Sunday. No stream on Sunday because I'm adopting a bunny. This is Bambini. This is Bambino. This is Kyori Pedori. A 4-year-old dwarf. He has tiny ears. Look at her. She's the cutest patutest. Look at her snuffle. He has a snuffle nose. And she has short ears. And she has cute paws. She's so cute. Yes, this is Bambino. Anyways, what we're talking about, physics, yes. He breathed in the alpha part and shortly after developing cancer, his voice went squeaky. No, are you serious, Cake? Bambino! So officially her name is Bambi, but we're calling her Bambino. The Foster family referred to her as Bambino, and I thought it was great. If the lab is still here in 5 minutes, it's a noble guess. That's actually interesting. Okay. So I kind of want to find out about this experiment he did. So it was on thorium, a substance which itself is radioactive. So they worked on a lot of elements: thorium, uranium, and radium, which they actually got from Marie Curie, which was really cool. They were in contact with Marie Curie and got the samples of radium from her. There we go. They did study half-life. Invariable of the size of the material that they obtain, no matter how much they get it, the time taken for it to decay would still... You're on the money, Boom. You are on the money. You said it. You said it to the chat, Boom. You are good, the god of the chat now. What you say goes. What you say goes. I did. You did. You absolutely did. You said that he just... I don't know if he devised the equation or... Okay, so it says he coined the term half-life. I don't know how much study they did on this. Did they do it for all of them? How much did they do? Did they develop the equations? Was it mathematical? I'm not sure. But they did term the coin half-life, and they did determine the half-life of certain materials and realized that it didn't matter how much of the sample they had, the half-life would still remain constant. Yeah, that's right, Campo. We'll get to that in a bit, but hopefully we'll talk about the earlier ones. Also, did Valve sue them for copyright infringement? He should get the royalties. Yeah, his family should sue. Absolutely. Okay, so no, this doesn't talk about the experiment. I want to talk to you guys about the really, really cool experiment. I can't find any science article on this. So, and I don't want to spout this without reference. It's really dangerous to spout nonsense without reference. So I'm going to tell my story, and hopefully maybe you guys can find an article about this, because this is amazing. So, sit back, relax. Story time. No, not the gold leaf experiment. Everybody knows the gold leaf experiment. Hi, Sicko, welcome in. What he did was he put a sample of something that was radioactive, that was radiating alpha particles, and I think it was thorium. And what he did was he put it in a very thin sheet of glass. Now I'm paraphrasing a story that I was told. I need to back up the story. And he put it into a thin sheet of glass. And outside of this glass, he also put he airblowed another glassblowed another glass container, a much thicker layer. And so what he did was he put the thorium in the thin glass. He was very good at blowing glass, absolutely amazing, and covered that thorium with a thin piece of glass, and he left it overnight. And so what happened was the alpha particles decayed out of the thorium overnight. He comes in the next day, and what does he do? He has 2 voltage points, two wires at the end of the big glass container of the thick glass, and he lights the shit up. And what he ended up doing was the whole chamber lit up as if lighting up helium. Now, this was a very well-known science at the time of heating up and lighting up helium, burning helium. It had a very distinct glow to it. And so when he lit it up, it had the distinct helium glow. And so he was able to prove or demonstrate that the materials that were radiating alpha particles, they didn't know what they were at the time, was in fact a helium nucleus. I don't know if they said helium nucleus or did they say it was a helium atom. I think they didn't know it was charged at the time and assumed it was a helium atom. I could be wrong. Again, I'm not referencing anything right now. I have nothing to reference. I'm just telling a story that I know. Is glass blowing still a lab skill or is it very... I know how to blow glass. It is called blowing glass, right? That sounds bad. But I learned how to blow some glass in the lab. A lot of my experiments, I don't know why it sounds very conspicuous, very weird. So I did very basic stuff, you know, test tubes and very small capillaries, bending them, cracking them, smoothing out areas that were cracked or broken. But one of my setups in the lab, one of my chapters in my PhD thesis we did actually have to hire someone to glass blow a certain kind of setup that we had. And we didn't do it in a commercial way. We actually contacted someone who we knew worked in a lab, just like a normal physics lab, who was just a very good glass blower. So we commissioned it, but it was a very custom made experiment. So I think it's both. It's both commercial, but I think you are taught it. I was absolutely terrified of doing any glass blowing though. The flame is so hot it's directly from a gas as well. Oh, I don't know, it's terrifying. Yeah, to me it was very, very scary. Hi, July. Glass is just a weird... No, I don't think glass was the problem, science bitch. Hi, by the way, if I didn't say hello to you. I think I need to take a little break. So I would like to point out that what I just said is again from memory and from paraphrasing another story, and I could have said some things wrong. I'm not referencing anything. I am coming up with this on the spot. But yeah, that's the story behind it. And I want to read about it. It really is a fascinating story. I really want to know. And as Nate was actually was telling the story, and the book that he referenced it from, he couldn't find it. And so we can't even find the book. I need to find it. It's such a fascinating story. All right, I'm going to go to the bathroom. I'll be right back in a couple of minutes. Everybody get up, stretch, grab a drink, do some jumping jacks, and we'll be back with some more Rutherford. I know I usually finish my physics sections around this time, but I'd like to talk more about Rutherford. Oh. So he was doing a lot of work with radioactive materials, and he discovered that the alpha particles being radiated, i.e. alpha rays, are basically helium atoms. Very, very interesting.
And they call it a mine.
A mine! Sugar Glider, thank you so much for the resub. Absolute worst probability and random signals. That sounds traumatizing. I wouldn't want to teach that. Welcome in, welcome in. Gold leaf experiment, dude. Yes, but we're not even getting to the gold leaf experiment. I'm trying to explain a really cool story of where he, yeah. Anyways, we'll reel back in. We got this. So, Rutherford did this really cool thing at the time. What they were doing studies, they were doing a load of studies at the time on the sun. And because of the amount of helium around the sun, they predicted that helium was about 20 million years. I don't know how old it was, but roughly speaking, about 20 million years. And so when Rutherford was working on radioactive materials and found that there was alpha decay from all these radioactive materials, he concluded, sorry, I jumped to conclusion, but also we knew that we were losing helium. Helium is so freaking light that if it gets into the air, it goes up higher into the atmosphere, and it literally off the surface of our atmosphere yeets off. It is so light, we are losing helium by the minute.
And they call it a mine.
A mine. Alex, thank you so much for gifting a gift sub to Rutherford. Great username, really appreciate it. Stop distracting me, chat! As the helium is being yeeted off the surface of Earth,
and they
knew that there was a finite amount of helium on Earth. And so, because of all the half-life and all the studies, if Rutherford picked up a metal of uranium or radium or anything else that was emitting helium, he concluded that all the helium from the Earth was coming from radioactivity. which meant that if he crushed a piece of rock and measured how much helium was being emitted, he could age the rock. He could determine how old these rocks were. What he found out was that those rocks were over 1 billion years old. This was a wild and bold claim. Can't remember exactly how the story goes, but I think he was very nervous about making this information public because this was very controversial. The sun at the time of what they knew was only about 20 million years. At the time, they didn't know about nuclear fission or fusion, by the way. So now we know now in hindsight, but at the time they didn't know. And I think the story goes kind of, again, I'm paraphrasing, no proper recollection of this. I'm referencing nothing here, which really, really sucks. But it was a meeting or a conference of other lecturers, of other professors. And it could be Lord Kelvin. I'm not sure. It could have been another Thomson. I'm trying to remember who it was, who had proposed how old the sun was based on the helium concentration. But he only announced his discovery when that guy who had claimed how old the sun was dozed off asleep at the meeting. So as this guy is falling asleep, he goes, by the way, using nuclei dating, I've discovered that the Earth is much, much older than we think. Anyways, it was very, very controversial at the time. But yeah, that's the story. Finally, after an hour of shenanigans on the stream, I finally finished the Rutherford story that I had in mind. Thank you so much for coming to my TED Talk. That is all I wanted you guys to know. There we go. Full stop. Everything I wanted to say. And that's all I've been trying to say for the last freaking hour. That's it? No, well, that's the one story I wanted to tell you. An hour. We've been here for... Oh, that was exhausting. I'm so tired after that. Oh, my goodness. Thank you so much for all those bits and all those subs for Bambino. I'm going to spoil her so good. You've no idea. I feel this was some classic tofu. Shit, my fever is actually shooting through the roof. Heck. What are you doing to me, chat? What are you doing to me? The half-life of thorium is the age of the universe, right, or close to it? Is it actually? Are you asking, by the way, or telling me? I don't know. Sick Tofu, no. Yeah, so I actually I wasn't able to stream on Wednesday with Coraline and with Coraline or with Lana because I was unwell. And I had to take the day off work yesterday. I'm not sure what's wrong with me. I seem to have a fever. And that's it. As of now. Asking. I'm so sorry. I don't know. And today you found out why you shouldn't stream class. We'd ruin your lecture. So touch back on the light bulb thing. Would that have kept making light until the internal material? Oh, no, it's not even radioactive. It didn't even need to be. Are you talking about the helium and the blow glass and the glass blow? Yeah, no, it doesn't even have to be radioactive. It glows. I think it doesn't have to be radioactive. Helium just lights up. You know the way you have neon lights? You know the distinct light that noble gases have. This might be a bit of chemistry, so take what I'm saying with a grain of salt. But helium also lights up with a very distinct color as well, and that's how they knew it was helium, based on the color that was emitted as the voltage passed through it. So we had an infinite light source. I'm not sure. I forgot how it lights up again. I don't remember the physics of it. How do noble gases light up? So when an electron current passes through them, is it just an excited state, I wonder? Maybe they don't break apart. Maybe they can be infinite. Most of these gases are used into space because of their chemical inertness. Okay, so they are stable and will not react. Do they stay infinite, I wonder? To my relief, Kelvin fell. Oh, you found an article. Where'd you find it, Hax? Okay, so Hax is quoting. Rutherford wrote, "To my relief, Kelvin fell fast asleep, but as I came to the important point, I saw the old bird sit up, open an eye, and cock a baleful glance at me. No, is that the truth? Oh, I'm so glad you. Where'd you find that, Hax? That article. So, just a reference again. So I was paraphrasing a story where Rutherford was going to boldly counteract what Lord Kelvin was talking about. And so he saw that Kelvin was asleep, was about to announce a secret shady thing. Oh, it's on. Oh, Jesus. That is not a link I would have thought. Radiometric dating. There we go. Okay, here's the whole paragraph. I'm going to read this. So they determined at which radium produces alpha particles, and Rutherford proposed that he could determine the age of the rock by measuring the concentration of helium. So by taking a rock and measuring the concentration of helium in it, he dated a rock in his possession to the age of 40 million years. Rutherford wrote when he was addressing the Royal Institution in 1904. Oh, this will make a great reel. Okay, we're ready for this. "I came into the room, which was half dark, and presently spotted Lord Kelvin in the audience and realised that I was in trouble at the last part of my speech, dealing with the age of the Earth, where my views conflicted his. To my relief, Kelvin was fast asleep. But as I came to the important point, I saw the old bird sit up, open an eye, and cock a baleful glance at me. Then a sudden inspiration came, and I said, Lord Kelvin had limited the age of the Earth, provided no new source was discovered. The prophetic utterance refers to what we are now considering tonight, radium. Behold, the old boy beamed upon me." Is that Ernst? Yes, it is. Welcome in, Christy. I love that. Absolutely love it. Thank you, Hax, for finding it. I'm so glad because I couldn't find anything. Like, I knew of the story and I couldn't find any proper reference. And I'm so glad I got most of it right as well. Thank you for that. What happens when the helium is gone? As in, what do you mean, July? What happens to the Earth when the helium is gone? Oh, it's such a fascinating history, Wombat Hole. I really love the history of physics. I'm very, very, very much enjoying. Maybe it's because of all the dry physics I learned. I know it sounds mean, but it was very mathematical and heavy on theory and stuff. And it's so nice to go back over all the physics that I've studied, but with a bit of a history tang to it. Oh, we don't talk about that, Christy. It's fine. It's fine. Yeah. So I heard that Rutherford is on the New Zealand $100 bill. Can you demonstrate how one cocks a baleful glance? Okay, let me practice this. So let me pretend I'm Lord Kelvin. I'm dozing off at the society. Here we go. How was that? I think I should be hired as an actor. What do you think? %. Excellent. Thank you. Thank you. Thank you. You're far too kind. You're far too kind. Encore. Ah. identify emote. Thank you, Fizzer, because nobody needs to know what else my face looks like. Oh, the color of helium is very pretty. It's like a very purple color. Anyways, again, thank you so much, Hacks, for finding that article. Perfect article. Oh, Resident Evil games, they're one of my favorite of all time. Resident Evil 4, the original, was my favorite childhood game. Top tier. I think it ranked #1 when we ranked best games ever. So that was kind of the two stories that I had in mind about Rutherford, and I got really, really distracted. Tarek! Why are we clipping these? No! Actually, what's the tofu? Well, what's the tofu command, Tarek, again? So are we really running out of helium, or is it just being created all around us? So we are running out of helium because I think the rate at which the helium is being produced via radioactive material, Beltrazi, counters the amount of helium we're losing. There's an imbalance at the moment. Resident Evil 4 childhood, right in the olds. Is it that bad? I was a teenager, to be fair. I wasn't like a child. I was a teenager. So do you remember a few days ago, I was talking to you guys and I was saying how I actually struggle with words sometimes. You know, there's different forms of intelligence, and one of the things I struggle is with names. But it's not just names I struggle with, it's words. I forget words all the time. And I don't know why. It's a very weird thing that happens to me. It is enhanced slightly when I'm in cucumbered, sobered. Word I'm looking. I'm a goody two toshu.
And they call it a mine.
I'm a goody two.
A mine.
I'm a goody tofu. Goody two shoe.
What you just said is one.
Oh, my freaking Twitch is collapsing.
Call it a mine.
Mine. Gertrude, thank you so much for resubbing for 3 months at tier 1. 13 months. Let's go. Welcome in, Gertrude. Aphasia? Is that what the proper word is? Ethanol enhancement. So yes, that was a clip of me just forgetting how English. I'm a goody two toshu. Okay, my Twitch is actually crashing on me. Yeah, it's the word for people unable to think of a word. Okay, because I guess. But is it like a proper? Aphasia is a clinic. Okay, I don't think it's fair to say I have that then. It's a common thing that people spend cramming information in their brains. Aphasia is a specific thing. Okay. Put out some Baldur's Gate music again. Lithologica also applies. I am lithological. Does that make sense? Did I use that word incorrectly? Lurk away, Gertrude. Oh, okay. That doesn't sound like what I have. No. Is hippopotamus philophobia, fear of long words? Ah, yes, of course it is. I feel like I couldn't say that word. Then, after all of that awesome story about radio dating with Rutherford, then Rutherford went on to actually do the thing that that is infamously known by most people. So most people associate Rutherford with the gold foil experiment. So let me explain what the gold foil experiment is. I don't, like, again, I'm paraphrasing. This is very crude, you know, just bear with me. So the gold foil experiment, just to give some background, was basically a very, very thin sheet of gold. Very, very thin. Like pretend it's like one atom thin, but it was several atoms thin, of course. Like a sheet like this. You can imagine that there was atoms in there. Gold foil atoms, tightly packed. And so, what Rutherford did was he bombarded I hope there's no illegality to drawing a gun, but this is like an alpha particle gun. He bombarded, it wasn't actually him, it was the student who did this experiment, but he did propose it. He bombarded the gold foil with alpha particles, and on the other side was a detector. I don't know how big the detector was, but there was a detector on the other side. And so he was measuring the amount of alpha particles detected by the detector. And you noticed that, you know, a lot of particles were detected, which made sense. Well, it didn't make sense. So yeah, so what he was able to prove or show I'm only pausing here because I'm thinking. He was able to show that atoms are made up of mostly free space. That was the cool thing about it. So you're bombarding alpha particles and they went through, which meant that atoms were made up mostly of free space. So you had a nucleus and the atom was theoretically huge, like massive in space. But I was wondering if they already knew that alpha particle was positively charged. They have to know that an alpha particle... Yeah, sorry, boom. I think my brain is thinking they must have known that alpha particles were positively charged for this part of the experiment work. So as one day... So there was a student doing this experiment, recording the result, the amount of alpha particles going in, the alpha particles going out. And he meets Geiger down the hall basically one day. And he was walking by, he walks by and he goes, I was just talking to one of your students and they were like doing the experiment and we see the normal thing, you know, the alpha particle goes in, the alpha particles goes through the foil. And Rutherford is kind of sitting there and he's thinking and he goes, tell my student to put the detector behind the gun. Geiger thought, sure, okay. Maybe you're recognizing the name Geiger if you are familiar with the name. And so what they do is they grab this detector and they put it over here. Now, nothing was detected at first. The student didn't detect anything. He bombarded the alpha particles, they went through. But then, the detector lit up. Then, another detector lit up. Then, maybe you're seeing it. It was nowhere near at the rate of the detection when it was on the other side. But ever so often, they did detect those alpha particles. So, this was wild. To me, what is so fascinating about this experiment is the frickin' jumping conclusion. I would have been like, oh, my gun is faulty. It's clearly shooting some alpha particles backwards. That's what I would have thought. But what he was able to show was not only now was the atom mostly made up of free space. The center of the atom was positively charged. What was happening was most alpha particles were going through, because an alpha particle is basically a positively charged helium, right? But if an alpha particle came really close to the positive charge, do you remember your electrostatics? Two positives repel each other. And if one went head-on collision with the nucleus, the alpha particle will be deflected directly back into this detector. That is what they were able to, using this experiment, they were able to uncover. Number one, that atoms are made of free space mostly. And number two, the nucleus is positively charged. So this experiment was absolutely amazing. And more than anything, what's incredible to me was the conclusion that he came up with. And all of these things, I talked about the glass blower with the thorium inside and measuring the helium and lighting it up. Amazing glass blowing skills, by the way. But also this experiment. Rutherford is the epitome and the classical description of an applied physicist. And I cannot give him enough credit to his mind of how he worked. His experimental physics, first of all, guts and intuition was incredible, but just the concepts that he came up with. Because his experiments, here's the thing. What's so incredible about his experiment is that it wasn't any advanced tech. It wasn't an advanced detection or like those machines that you see in sci-fi movies with loads of like monitors and LEDs and boopity boopity bops. His experiment was, all of his experiments were so fundamentally basic and simple. And you might say that might come off as an insult towards Rutherford, but it's not. It shows that his results are indisputable. Because his experiment is so fundamentally basic and unarguable and ideal that you just couldn't argue with it. How do they make alpha particles? Is it easier or some super high tech? Sorry to sidetrack, but how do right now? How do they make alpha particles? I'm guessing they collected from radioactive material. And the peaks and troughs depending on the angle of the initial alpha particle. So if it does alter based on the size of... Sorry, I don't know if the question is right. I would assume that it's a beam, Zir. Like a linear beam directly from the gun. I'm not sure though. I don't actually know how the alpha gun worked. Okay, Halation and Boom are saying that it's radium. Oh yes, we have radium as well. Yeah, you're right. It is radium usually. I mean, I don't have radium, I promise. My research group, my research department, they do nuclear physics, so we have some nuclear particles in a hidden lead protected room somewhere, secret. Which is super easy in setups. Exactly, Beltrazi. There really is something really, I don't know how to explain it. I find the coolest experiments in physics, the coolest discoveries and discussions with experiments like this, where it was so paramount, not paramount, that's the top, but it was so fundamental and so basic that you just can't argue. You cannot argue with the results. You are supposed to be the scientist we trust hiding nuclear samples. Yeah, I'm trying to remember how gamma radiation came about. Who discovered it first? Oh, I actually think it might have been Rutherford. Let me think about this. So there was some particles that were emitting alpha, and then he discovered that some sort of energy was still bypassing the thick glass or something. I do remember a story like this. And again, I have no reference at all, and I apologize. I'm not making up these stories. It's just, my brain. And I have a really high fever, and I don't know what I'm talking about anymore, and I'm so sorry if I'm incoherent. Oof. I've just been sick for the last few days. Did it just make people sick when they're around it or something? Yeah, so radium gives out all three forms of radiation, so it's really good to study. I think it does. Correct me. But it is very good. It has good half-life, and it's good control as well. Radium is good in that way. That being said, of course, we know the story of Madame Skłodowska-Curie, who... a French chemist and physicist discovered gamma radiation while studying radiation emitted from radium. Okay, I got it wrong. Thank you, Tarek, for correcting me. So it wasn't Rutherford, but it was someone else who discovered it. And again, from radium. So at least I got the radium part right. I'm a physicist who spreads false information on the stream. Later in 1903, Liz's radiation was recognized as a type of fundamentally different from previously raised by Ernest Rutherford by analogy with the beta and alpha. Okay. Bruce Banner. There we go. So yeah, if you guys want to learn more about radiation physics on Sunday next week, so not this Sunday because I'm going to go adopt Bambino. Next week Sunday, I'm going to be on the front page of Twitch, you guys, if I haven't said it enough already. So I'll be doing a long stream, like 8-9 hours. I'll be starting 12 p.m. UTC, so I'm so sorry to my American friends. You guys are just not going to catch my stream. Please sleep. Please get loads of sleep. But on it, I'll be teaching alpha, beta, gamma radiation. We're going to talk about nuclear radiation and decay. It's going to be similar to something that we did about a year ago. If anyone has been watching the stream for this channel for a while. A little bit more advanced, ever so slightly, because I think we'll actually talk about the neutrino a little bit. And what I'm going to do is I'm going to focus or embed it. I'm going to write this myself. I'm going to write the whole lesson myself. Where I'm going to embed Curie's work throughout the physics. So we're going to do physics and history mixed together. And yeah, I'm going to be teaching on the front page for several hours, and then we finish off the stream by playing some Half-Life. It always sound like a tasty breakfast cereal to me. I mean, they're going through you every moment while you're eating breakfast now, so you're not far from the truth. We will be good lab rats from the front page. Yeah, I need to like prepare the mods a little bit, because when I was on the front page the last time and the first time, I was doing Mars physics. So we were doing like classical projectile motion and Newtonian physics, but on Mars. I thought it was a really interesting lesson, but there was a few people who were coming in with the comments being negative, saying this is high school stuff, this is basic stuff, and it really pissed me off. That's my like that's the thing that pisses me off, when people say this physics is easy when there's just a bunch of people trying to learn. So I need to prepare the mods in the sense that we'll prepare a message where I tell people, we understand this might be easy to you, don't be a jerk, you know, to give people a chance. Because sometimes I'll try to give people the benefit of the doubt that they're not trying to be jerks. I'll give them the opportunity to shut up, basically. And if they choose not to afterwards, then we ban them. Wait, did we say we're playing Half-Life? Yes, Alex. I'll be playing Half-Life on the front page next week, Sunday. So yeah, I'm not going to play any Dragon Age Origins, if that's okay with you guys today. Instead, we'll be playing Dragon Age Origins all day tomorrow. I'll start my stream at 2 p.m. I'll do a little bit of physics. Mostly I'll be talking about the electric grid stability. I'm going to draw Ireland, and I'm going to show some turbines and stuff like that in preparation for Science's stream. I'm going to be on Science's channel tomorrow as well. And we're going to draw some vanadium flow batteries and stuff together. So if you guys want to learn a bit about my PhD, about electric grid stability and why introducing renewables to a grid is a problem. And I know people are like, oh, Tofu, how dare you say it? I'm not saying that is a bad thing, but I'm explaining why technologically, why don't we have more renewables? I'm trying to explain what was the reason? Sorry. That's a very nice nipple. It's an atom.